Hello everyone, and welcome to this section of the Critical Thinking course, in which we're going to look at some of the arguments to do with human population in relation to global challenges. This week, I'd like to look at some of the facts about human population growth and what they might mean in relation to the challenges that we face in the foreseeable future. As I'm sure you're all well aware, we now live in a world with more than 7 billion people. This is the result of a dramatic increase in human population, which has really only occurred over the past 150 to 250 years. This is shown clearly in the information in this graph. As you can see, human population has been rather stable or gently increasing, in fact, over much of our recorded history. But in recent times, our population has begun to increase at a truly remarkable rate, so that it has nearly tripled, for example, between 1950 and 2012. At present, it's estimated that world population will increase by 1 billion every 15 years. By 2050, total population is predicted to be over 9 billion. As shown in this graph, the growth in population is not evenly distributed around the world. Most of the increase in population has occurred in Asia, notably in India and China, and in Africa and in other developing countries, while in the more developed areas of the world, including Europe and Northern America, there is either no change or a small decrease in total population. Notice also on this slide, which shows projected estimates until the year 2050, that the rate of increase is predicted to slow down by that time, and some predictions suggest that the total population might stabilize at around 10 billion after 2050. The remarkable recent increase in human population has its origins in the Industrial Revolution, which created new economic and employment opportunities, advances in public health, education, agriculture, transport, and global trade, and in the increasing availability of medicines and vaccinations all over the world. In parallel, there has been a huge increase in urbanization, the growth of cities, and for the first time in our history, the majority of us now live in cities, and there are now more than 20 megacities with populations of more than 10 million dotted around the world. There's a great deal of debate and concern about the future of human population and the effects this has on our global environment. To understand the importance of human population growth and its impact on global challenges, I'd like you to watch this short excerpt from a lecture that my colleague, Professor Paul van Gardingen, gave recently in the Changing World lecture series, where he introduces the topic of the perfect storm.
The perfect storm was introduced by the government's chief scientific advisor, Professor Sir John Beddington. The chief scientists exist within UK government to give the cutting-edge scientific advice which will inform policy and action over the coming years. And last year, John Beddington said, actually, we've got to start thinking on a longer time horizon, thinking about what is going to happen to the world as a series of challenges influence our behaviour. And he coined this phrase, the perfect storm, and mentioned that there are a whole range of major global challenges which are coming together. Some of the ones which were mentioned were things such as the rapid rate of urbanisation. We're now in a world which is radically different from the past, where over half of the population lives in cities. Poverty. We're in a world where a very large proportion of society is living in abject, absolute poverty. Energy, where in many cases energy is limiting people's lives. And where are we going to get the energy for our future needs. Water. We know that water is already limiting. Many parts of the world we see the effects of this in terms of droughts. We also see the exact opposite, floods, as we saw in Pakistan in recent weeks. Food security. For anybody who's been buying food recently, it's gone up. It's actually, some commodities have gone up over 50% in the last 2 years. And every prediction is that food security will become more and more an issue in the future. Biodiversity. Biodiversity this year is important. 2010 was the target that the Convention of Biodiversity gave the world to reverse the loss of biodiversity. Why? Because biodiversity is fundamental to life. It's behind agriculture, it's behind the forests which provide clean air, between the water. Biodiversity is a fundamental building block for life. And unfortunately, this year, the Convention of Biological Diversity had to say, well, we didn't do it. We're still getting rapid loss of biodiversity, more rapid than we have had in recent history. Climate change. Last year, there was a lot of discussion about climate change leading up to the Copenhagen Conference of Parties. And again, whilst there was a lot of discussion about the impacts of climate change and some discussion about what we need to do about it, we didn't really come out with a strong pathway forward. And then finally, going around the edge, we have infectious diseases. The obvious ones which we have heard recently are things like SARS, bird flu, but there's actually a range of emerging infectious diseases which have the potential to have quite severe impacts on people's lives. And at the heart of this, I've also put one of the fundamental drivers for this, which is population and demographic change. In the developed world, in Europe, demography is one of the major challenges. As population ages, where is the productive part of the economy? Who is going to look after the older people as they become older and live longer? Whereas in the developing world, there is a projected major increase of population, particularly in sub-Saharan Africa. At present, the prediction is that over the next 40 years, so up to 2050, population will increase by a further 3 billion people on Earth. Another 50% needing to be fed, to have clean water, to have education, to have energy, to have food. Is that possible? So the question behind the perfect storm is, if all of these things are projected to come together sometime over the next 20 to 40 years, how does global society adapt? What needs to be done? What does the future look like?
So I hope you can see, with an increasing human population living in cities, with their demands for food, water, energy, sanitation, living space and health services, these are at the center of many of the global challenges that we face in the foreseeable future. Now, given the importance of human population in the context of global challenges, it's obviously quite important for us to understand what's going on and try and anticipate what might happen in the future. Clearly, population growth is a balance between two things: average birth rate and average death rate. If the birth rate is greater than the death rate, then the population will increase, and conversely, if the death rate is greater than the birth rate, the population will shrink. The ideal and sustainable situation is when birth rate and death rate are about equal, so that there is a stable population through time. It is important to understand that the numbers in this graph represent a snapshot in time. What we really need to know is how populations change and what factors determine how they change. This is called demography. History shows us that in general, all societies go through a series of demographic changes called the classic demographic transition, as they develop from pre-industrial ways of living to post-industrial, increasingly globalized modern economies. To understand this demographic transition, have a look at this excerpt from another lecture in the Our Changing World series, this time given by my colleague Professor Roger Jeffries, where he explains the theory of the classic demographic transition model.
This is the classic ideal type demographic transition. Everybody recognizes that it doesn't apply exactly in all ways to all places at all times, but that on the average, for most places, in various ways, you can expect them to go through this kind of sequence. So, in the early periods, you have what's called a high stationary period. You have a high death rate and a high birth rate, both of which wobble around. They wobble around because of famines, because of wars, because of disease affecting the death rate, and those changes in the death rate also affect the birth rate. So in some years you might have population growth, in some years you have population decline, but no real trend is obvious. And these are at levels of about 40 per thousand population per year. The total population is relatively low, densities tend to be low, and relatively little change through time. In the second period, or the second and third periods together, the expanding period, fertility doesn't change very much, and mortality begins to fall. Mortality begins to fall for a variety of reasons, usually nothing to do with medicine. Doctors who actually treat patients aren't very useful at reducing mortality rates. They don't like to be told that, but it happens to be true. They're rather better if they're producing vaccines and immunization, but even that they're not particularly good at. If you really want to reduce mortality, you give people soap, you give them a little bit of extra food, you give them some advice on how they might feed their kids, you sort out aspects of sanitation, you deal with general living standards, and death rates fall. Birth rates don't fall at the same rate, and there are a variety of reasons for this. Some of them have to do with the fact that it takes time for people to notice that mortality has decided to come down. So the behavior that made sense in the early period continues with respect to fertility without anybody really thinking about whether it's a good thing or a bad thing. And of course, in that period, you get very rapid growth rates. Here we go. Total population rises very fast. And then as fertility declines, so the rate of growth of population declines, and you get back to a situation down here where mortality and fertility are at roughly the same level, and therefore population growth becomes very slow. In the final period, the fifth period, you get the possibility of natural decrease or of increase. In fact, there's very little certainty really about what goes on when you've reached low levels of mortality and low levels of fertility as to whether those are stable or unstable. So different countries at this period have very different trajectories.
Okay, so the demographic transition model gives us a systematic way of thinking about human population growth, not as a single scary large number that keeps going up all the time, but as a changing picture that's gradually evolving over time, with a rational explanation for why it changes in the way that it does. We can use this theory of demographic transition to try and predict what might happen over the coming years in developing countries, in developed countries, and in the world as a whole. For example, have a look at this next graph. This graph shows 3 possible predictions for total world population. As you can see, the worst case scenario is shown by the red line, if the present rate of population growth carries on unchanged. Total population will continue to increase above 10 billion by 2050 and double its present value, 14 billion, by 2100. The impact of this sort of increase on global challenges, as you heard about a little earlier from Professor Van Gardingen, is likely to be extremely severe, and this rate of growth is probably unsustainable. But, as shown by the orange line, if global fertility levels begin to decrease, as predicted by the demographic transition model, so the total population may peak at about 9 to 10 billion and then stabilize or gradually decline. Or alternatively, if we take a more optimistic prediction, perhaps the decline in global fertility levels will occur more quickly and lead to a declining population more quickly, as indicated by the green line. So, understanding the demographic transition model is a useful way of thinking about global population and the future changes that we might anticipate. For this week's exercise, I would like you to apply your critical thinking skills to the demographic transition model. Is it a good theory, a good explanation of how populations grow and change? How do we assess it? Is it supported by evidence? Does it make testable predictions, and is it credible? Have a look at some of the additional materials as well as you go through this week's exercise. Next week, we'll ask the question, is it really overpopulation that is the main problem that we face, or is it something else? I'll see you then. Bye for now.